Look at this simple Spring Boot service method. Nothing special, right? Just a standard payment method marked with the transactional annotation. Somewhere else in your application, you call it with a single line of code. It looks incredibly straightforward. One method call leads to one method execution. Most developers picture the execution flow looking exactly like this. The caller invokes the method, the code runs, and you are done. Except that is not what actually happens. In reality, something entirely invisible stands directly between your caller and your method. Every single time you call an annotated method, Spring runs its own code before your code even starts. It stops the request at the border and asks critical questions. Should I start a database transaction? Should I read from a cache? Should I run this on a separate background thread? Or should I perform a security check? Only after making those decisions does your actual method execute. This middle box, Spring Proxy, is the entire reason why annotations like transactional, cache, async, and secured work. They don't magically rewrite your Java code. They simply tell Spring, before this method runs, intercept the call and execute some extra logic. And sometimes that interceptor decides your method should not run at all. For example, when you use cacheable annotation, which finds a matching result already stored in memory, Spring simply returns the cached value and your actual method is completely skipped. Now think back to our previous videos. Why did transactional fail completely during class self-invocation? Why did your asynchronous tasks silently run on the same main thread? The answer is exactly same for every single one of those bugs. If a method call never reaches this invisible interceptor, none of your annotations can do their job. This invisible mechanism is called Spring AOP. But don't worry about the textbook terminology yet. In the next section, we will look at exactly why Spring uses this design and how it keeps your code clean. Now we know something interesting. There is always an invisible interceptor standing between the caller and your method. But why? Why doesn't Spring simply add transaction code inside our method? Let's look at a simple order service. Imagine Spring modified our method directly. It would have to look something like this. This looks okay for one feature, but what happens when you add cache? You have to manually add cache checking code. What about async annotation? You have to add thread pull logic. What about security roles? You have to add permission checks. Very quickly, every single method in your application becomes a messy, confusing soup of business rules mixed with framework code. That would be an absolute nightmare to maintain. This is why Spring uses a much cleaner design. Your method contains only business logic. Everything else stays completely outside the boundary. If we peek inside this proxy wrapper, we can see exactly how it stacks multiple annotations seamlessly. Notice something beautiful here. Your service method never changes. Whether you add one annotation or 5, your business code stays exactly the same. In software engineering, this is called separation of concerns. Your code focuses entirely on business logic while Spring handles transaction, caching, security, and threads cleanly from the outside. 4 completely different annotations, but they all use the exact same mechanism. One interceptor, one proxy, and one centralized place where Spring adds extra logic. Now that you understand this concept, you are fully ready to give names to the pieces. So far we have learned one simple idea. Every method call first reaches a Spring proxy. The proxy performs some extra work. Then your business method executes. Now let's give names to each part. First, what is the extra logic that Spring executes? Starting a transaction, checking the cache, writing a log, performing a security checks. The extra logic is called advise. It's simply the action that runs. Second, should this advice run for every single method in your app? Probably not. You need a rule to filter your targets, like only methods inside the service package or only methods marked with annotations like transactional. The rule that selects which methods get intercepted is called a point cut. When you combine a targeting rule with the actual logic block, you get a clean modular component. That combination, point cut plus advice, is called an aspect. Now what about join point? A join point is simply any physical place in your code where Spring has the opportunity to intercept a call. In Spring AOP, that means any public method execution inside a Spring bean. Finally, how does Spring connect your code to the aspect? When your application starts up, Spring analyzes your beans and automatically weaves the proxy layers together behind the scenes. This setup process is called weaving. Let's put everything together. Now we can map every AOP term into something we already know. See how simple that is? We don't memorize dry definitions. We just name the components of a picture we already understood. Now let's look at the real power of AOP by writing our own custom aspect in less than 10 lines of code. You got one task that you want to log the exact execution time of every single service method in your application. Most developers open up their files and start manually writing logic inside every service, like order service, and duplicating it inside payment service and copy pasting it a third time inside user service. Suddenly your clean business code is buried under infrastructure cluster. Soon every service looks like this. Now imagine one simple requirement: change the log format. So you have to go back and manually update hundreds of methods. This is a classic cross-cutting concern, a generic task that cuts horizontally across your application. Instead of putting logging inside every method, let's pull it completely outside into a single reusable aspect. That's it. Just a few lines of clean code, no changes to your order service, no changes to payment service, and no changes to user service. Spring automatically applies this logging aspect across your entire service package using our proxy layout. Your business code stays focused on purely business rules, and your cross-cutting concerns live in one single reusable place. But notice a specific annotation inside our custom aspect around. What exactly is around annotation and how does it differ from alternative hooks like before or after? Let's map them out on a timeline. In the previous section, we created a custom aspect, but look at this line again. Why did we use around? Why not before or after annotation? The answer is very simple. Choosing between advice types comes down to a single question. When exactly do you want your code to execute relative to your target method? If you only want to log that a method has started, use before advice. It is exactly what you need. If you only want to log information or clean up resources right after a method finishes its work, you use after advice. It runs immediately as the method exits. But look at our custom aspect, we use around advice. It acts completely differently because it wraps your code completely. Around is the most powerful advice type in the entire framework. It gives you absolute programmatic control over the execution loop. It can run code before the method, run code after the method, modify the final return payload, or even choose to cancel method execution entirely. This is the exact mechanism driving Spring's enterprise caching system. When a client requests data from a method marked as cacheable annotation, the proxy checkpoint intercepts the invocation and searches a cache pool first. If the data is found, the proxy short circuits the pipeline and returns the cached value directly. Your database heavy method is entirely skipped. This optimization is only possible because cacheable annotation operates as an around advice. Everything aligns perfectly now, but before you push your custom aspect to production, we need to address three critical traps where Spring will completely and silently ignore your code with zero warnings or errors. You have seen this before in the transactional video. The same proxy mechanism means the same silent failure applies to every aspect you write. The application starts successfully, there are no exceptions and no compilation errors, but when you hit your service in production, your aspect never runs. Let's break down the three most common structural reasons for this silent failure. Look at this code example. We have a public placeholder method calling an internal notification method within the exact same class. Most developers expect the internal call to pass through the proxy and execute our logging aspect, but it won't. Because placeholder invokes notification, the call never leaves the local instance object. It completely bypasses the Spring Proxy checkpoint. No proxy means no interception, which means your aspect is completely skipped. This is the exact same reason why transactional and async fail during internal class self calls. The fix is to extract the target method into an independent Spring bean so that invocation is forced through a proper reference. Now consider our second scenario, aspect on a private method. This looks perfectly valid. Application starts, no errors, but Spring never executes it. Why? Because Spring Proxy can only intercept public methods. Private methods stay completely invisible to the proxy. The third failure mode happens when you write a flawless aspect class but forget to add Spring's core stereotype marker at the top. Without component, Spring startup class path scanner ignores this file completely. The aspect is never registered inside the application context. No proxy behaviors are generated and your code runs completely unprotected. Simply add component to tell Spring to manage the lifecycle. Now you understand AOP, which means you understand async annotation. It is just another aspect. Spring intercepts the call, submits the method to a thread pool, and returns immediately to the caller. Sounds perfect for background tasks, and it is until you use it wrong. Async has two failure modes that will silently run your method synchronously. Blocking the caller thread with no exception, no warning, and no indication anything went wrong. That's the next video.